Hi, everybody. My name is Fraser Cain. I am the publisher of Universe Today, and this is your weekly space hangout for June 21st, 2012. This week, we're going to be talking about black holes working as particle detectors, the new advances in the Chinese space exploration, asteroid research, and the history of women in space. So joining me this week, we've got a bunch of our regulars. We've got Alan Boyle from MSNBC's Cosmic Log. We've got Shira Teitel from Vintage Space. We've got Ian O'Neill from Discovery Magazine. And we've got a new victim this week. We've got Michael Wall, who is one of the senior writers at Space.com. Hey, Michael, welcome to the Weekly Space Hangout.
Oh, hi, thanks for having me.
Now, I know you've got a roll at around 10:40, so feel free to drop out as soon as you need to, and
okay.
Just disappear without a trace. Even if we're in the middle of talking, it's totally fine.
Okay, sure. I'll be as rude as possible.
Yeah, exactly. Yeah, I'm out of here, and then just hang up. So that's great. All right, cool. Well, let's get rolling then. So as always, we're going to sort of present the big stories that broke this week in space and astronomy, and then at any point, if you guys want, anyone watching can ask any questions of the panelists. You can post a question on the Google Plus post where this recording is happening. You can also, if you're watching this on YouTube Live, you can post a question over there. If you're watching this on CosmoQuest or embedded on some website, you can also use Twitter and use the hashtag Space Hangout. Although I think Twitter's down, so maybe you can't. You're going to have to come to Google Plus or YouTube. All right, well, let's get started. I think we're going to start with Ian, who has not been around for a little while. We'll see how rusty you are. You working on an article about how black holes could be used as particle detectors.
Yes, I am a bit rusty, and especially with quantum physics, so I won't go into that. But there's some interesting research out of, I think it was Vienna University, and they've basically come up with the idea that perhaps black holes could be used as like giant particle detectors. So you can forget the LHC for this. This is something on a far grander cosmological scale. And in particular, they're looking at axions. Now, axions, they are hypothetical quantum particles, and they're very weakly interacting. So that's why we haven't discovered them yet. So they're almost like WIMPs, and trying to find these very weakly interacting particles. And they're supposed to, because they got very, very, very low mass, but there's supposed to be many, many of them, almost like neutrinos. And their collective mass is supposed to contribute to the dark matter that's supposed to pervade most of the mass in our universe. So they're kind of important particles to study, but we haven't found them yet. So this group in Vienna, they decided to have a look at black holes because, of course, black holes, they suck in everything because they use massive gravity to suck in everything, including light. And what may happen, and their calculations seem to show, that in the weird quantum world of subatomic particles, particles can act like particles or they can act like waves. And depending on their mass and depending on their qualities, they can act more like waves than particles. So in this case, these axions, they actually act more like waves. They actually act more like photons. So they've got very, very long wavelengths. So they may, because of their quantum characteristics and because of the gravitational heft of a black hole, these axions may actually use black holes almost like as supersized atoms. So they actually orbit the black hole. They treat it like an atom. And the interesting thing about axions, they're bosons, so they're very collective. Bosons, they don't care. Their quantum states, they can mix as much as they like, whereas other quantum particles like leptons, they can't occupy the same location at the same time. Bosons are more social. They can act en masse, and there can be a massive collection of these bosons surrounding black holes. Now, the interesting thing is, how do you actually detect these things? Because we're talking about subatomic particles over millions of light years. How do you actually detect them? But because these axions, they act en masse, there's a massive swarm of them theorized to be around black holes. Their gravitational heft gets so big that if they suddenly collapse or if there's sudden changes in the environment around the black hole, they may generate gravitational waves. This feeds into another cosmological study of trying to detect these gravitational waves, basically these ripples in space-time. We haven't actually detected any yet, but Einstein's theories of relativity, in fact, here he is, I'll show you. There's Einstein looking over us right there. He's giving us a very knowing look. He predicted that these waves in space-time do exist, and particle detectors on Earth, they're currently trying to find them. So that's one thing that perhaps we may be able to do, is to use these black holes as particle detectors to actually detect these swarms of axions around black holes. I mean, it's out there, but it's not too crazy, but it's something that we're not going to probably find out for another 10 years or so, but it's certainly an interesting field of study.
And are there no really good strategies for detecting these particles with some kind of super colliding, superconducting device here on Earth? I mean, is this the kind of environment that's necessary to generate these kinds of collisions?
Well, apparently, I mean, axions, they require very little energy to be produced. And I actually think the researchers are actually suggesting that these axions may be generated by a black hole. They may be generated around the outside of the black hole by some interaction with space-time. And so it becomes a nice environment for these particles to be generated. But just because these black holes have such a gravitational influence over space-time, they trap them in orbit around the black hole. So they may generate a lot of these axions, and they may stay in orbit. On Earth, I'm sure that they can be generated, but they're just so weakly interacting that we can't detect them, and there's no way of trapping them, whereas a black hole has got a means of trapping them and ultimately ultimately collecting them so they can be detected from their mass, from the gravitational waves they're ultimately produce. So yeah, they're just very weakly interacting particles. They're almost like neutrinos. Neutrinos are very, very difficult to detect, but we can detect them by creating these huge vats of like purified water, and you can detect the flashes as they hit particles within that purified water. But with axions, they're even more weakly interacting than that. It's very, very difficult to find them. So so we have to find secondary ways of detecting these particles, and so perhaps their collective gravity may actually reveal them.
There's a lot of ways that people discover these kinds of phenomenon. On the side, they don't realize, they're not looking for these things necessarily directly, but some cases, they use Hubble, they look at the moon to detect changes in sunlight, or they're able to detect, reflected X-ray radiation coming off of Jupiter that's coming from the sun. So there's a lot of these kinds of situations where they can use these, even the way they detect cosmic rays, right? You can't see them from on Earth, but they use these high-energy telescopes to detect them after the outflow of particles as they've made it through the atmosphere. So there's ways that you can detect these things, not directly but indirectly. So I think that's really cool. Well, let's move on. Let's bring Michael in now for his first crack at reporting some space news here on the Hangout. And so, Michael, you've been covering the launch of the Chinese Space Agency's launch, including the first female Chinese astronaut.
Yeah, well, and that actually happened last Saturday on the 16th, and I don't know if they chose that date with this purpose in mind, but that was actually the 49th anniversary of the first woman in space. Valentina Tereshkova launched on June 16th, 1963. So, I mean, whether that just worked out for them or that was something that they had wanted to do, I'm not sure. But so there are three of them still up there, taikonauts, as they're called, Chinese astronauts. And it wasn't just groundbreaking in that they launched their first female astronaut. They actually made their first manned space docking, and they joined the U.S. and Russia as the only three countries that have ever done that. So they're still up there. This is viewed as a big step forward in their plans to eventually loft a full up and permanently staffed space station in Earth orbit by 2020. It's not going to be as big as the International Space Station, which is about 430 tons. What China's thinking about doing is about 60 tons, so it's going to be like a smaller version of that. But they've got big space plans, and they're just kind of ticking off the milestones on the way toward accomplishing those goals. They've also said that they want to put a man on the moon, or I don't know, maybe a woman on the moon at some point after they get that space station up and running. So, and this is something that gets a lot of people in the West a little nervous because China's space program, I mean, it's run by the Chinese military, basically. They're in charge of the space program. And of course, we've got a complicated relationship with China. I mean, we're huge trading partners, obviously, but they have made no bones about their big plans to kind of overtake us in a lot of ways economically, and some people fear also on the battlefield. So this is something that people get talking about when you see something like this, China making a big space advance. But yeah, they're still up there. I mean, it was said that they'll probably be up there. The space mission will last about 13 days, and they're going to try out some more technology. Their very first docking was all done by. It wasn't actually like they were driving to the space station that they launched up there. They actually launched in a space capsule called Shenzhou 9, and they actually just kind of joined up with a small space lab that has been up there since last September. That's actually called Tiangong 1. And so the first time that they docked with Tiangong 1, it was all in remote control. They weren't driving. They're going to pull away and actually let the astronauts do, a manual docking at some point too, just to sort of further refine all of the technologies and the skills they need to do this. And yeah, these are technologies that they're going to need to be proficient at to build a space station in Earth orbit, which is the whole point of this whole exercise. And it's interesting to note too, China, they do want to do this partially because they're not in the big international coalition that is now cooperating on the International Space Station. They were pretty much kept out of the International Space Station primarily due to objections from the U.S., is what most people say. So yeah, it'll be interesting to see where this mission goes. They still have to land, obviously, so it's not a complete success yet. But yeah, China has said that they probably want to actually launch another crew to Tiangong 1 later this year, probably in the fall, and they're going to keep on ratcheting up their manned space program by the looks of it. So it'll just be really interesting to see how it works out. And it's interesting too because there's a lot of doom and gloom attached to the U.S. space program or the manned space program in a lot of people's minds because of the retirement of the space shuttle, and we currently don't have a way to get astronauts to space. We have to rely on the Russians now and all this stuff. And so a lot of people see their rise kind of in concert with all with our kind of fall in manned spaceflight. Of course, if you talk to NASA, they say it's all part of the plan. We're going to shift that stuff over to the private sector. The private sector, look at SpaceX and all the other the private spaceflight companies that are on the rise. But so yeah, it's just a very interesting time in manned spaceflight, and it'll be interesting to see what China does over the next few months and years.
It really feels to me like they've been moving very steadily and very deliberately, stage after stage, without any of the bureaucracy and kind of political shenanigans that have been happening with the International Space Agency. It's just like, we're going to launch a person, then we're going to launch another person, then we're going to launch a space station, then we're going to dock to the space station, and they've been just hitting those milestones with very little fanfare and very little difficulty, and it's, I don't know, it almost feels like them being barred from participation in the International Space Station has been a bit of a boon, because you said it's sort of run by the military. They're just like, you people, launch to space, get on it,
And there are pros and cons about being in, I don't know, like one-party totalitarian state. If they want to do something, they can do something. I guess that's a pro. And there are a lot of cons attached to it too. You can't say anything bad about what they're doing if you're a normal citizen, or you, I don't know, risk getting censored or have some people put on you, whatever. But yeah, they don't have to go through the same checks and balances that we're used to maybe in the West. If they decide that they want to launch an astronaut, then they're just going to do it. And there isn't that much of that same kind of bureaucracy that we're all used to in the U.S. especially, just like they don't have the same kind of checks and balances on a lot of their political system that we're used to. If they want to do something, they just go ahead and do it, better or for worse.
How do you think that this sort of their rise and their exploration is is different from the space race that happened back in the 1960s. I mean, do you think that it's going to end up with them getting to the moon and then, you know, never going back, or do you think that there's sort of at this point a sort of a never-ending series of discoveries and advancements they're going to be making?
Yeah, I mean, I don't really know. I'm not sure, and I mean, a lot of the people I've talked to about this aren't really sure. I mean, pride is a big part of it, I think. I mean, I think that they want to show that they're capable of doing the same things that the U.S. has done, and putting a person on the moon, I mean, that would be a huge symbolic act and a huge national accomplishment. I'm not sure if the ultimate goal is to have like a lunar base that would contribute to their economy, or I don't know, their military activities even. I'm not really sure if that's certainly what a lot of people fear, but and because yeah, obviously space is like the ultimate high ground on the battlefield, and that's primarily why we here in the U.S. have been, I don't know, probably the world's dominant military power since the dawn of the space age, is because our space assets have been so dominant over the rest of the world. So that's another aspect in all of this. If, I mean, China keeps making space advances, and obviously if their space program is sort of run by the military, then those are, worrying developments for a lot of people in the U.S. military and all our allies. So that's another sort of thing that just kind of goes along with this. It's another little, worry that folks see with the advance of China's space program, is because if you're a very dominant space power, then you tend to be a dominant military power too.
I think that's the big thing, is that it's really just a demonstration of their military strength. I mean, if you can launch into space and you can take the high ground, then I think that demonstrates that you're a serious contender on the sort of global stage. So I think that's really key insight, right?
Yeah, and you think about, if you launch all of these spy satellites, that's like primarily how we get all of our good intelligence and how we know where all these Al-Qaeda folks are and stuff like this, how to target. Whether you think the drone strikes are being targeted directly or not, or like very accurately or not, a lot of that has to do with our great satellites up there, which a lot of people don't know very much about because they're very classified. But if you have a great space program and you have this technology, yeah, you can just learn so much about your adversaries. You can learn so much more than, I don't know, most of us even probably know is like going on with the U.S. military. I mean, I'm sure that there's a lot of stuff up there we have no idea is up there and is very competent and very advanced. And there are a lot of people here who are worried that we're going to lose that sort of military edge.
Now, Amy, you actually wrote about this anniversary between the Chinese launch and the sort of the Russian launch.
Yeah. Like Michael said, I haven't found any evidence that they picked the date of the launch to coincide with the anniversary of Tereshkova's launch, but there are a lot of similarities between the two of them. I'm always reluctant to say anything, but they're both coming out of totalitarian states, and in both cases, launching a woman has a lot of, there's no reason that women can't be astronauts. We know this, but it means a lot in these totalitarian states to put a woman up. And it kind of has this connotation of, well, we value our women as much as we do our super powerful men who've been doing this stuff beforehand. So I'd tell a little bit of the story of Tereshkova's launch, and if anybody has any thoughts on the Chinese launch over the weekend, please draw more comparisons with me. So the idea to put a Soviet woman into space actually came up in 1961. The Soviets were maintaining a nice steady lead over the Americans, and it was Sergei Korolev, their chief designer, sort of the Soviet version of von Braun, if you will, who decided, okay, well, why don't we just do this? Let's put a woman up. She would be in a Vostok, which gave the astronaut, or cosmonaut rather, basically no control. So there was no reason not to. On February 16th, 1962, 5 women were selected out of 400 applicants. The only sort of markers they had to meet was they had to be under 30 and shorter than 5 foot 7 inches. In Tereshkova's case, she was a well-respected parachutist, which was good because they did not get to land on land. They had to eject out of the Vostok and land by parachute. So she had that going for her. So they joined the men, these 5 women joined the men, and when it came down to it, it was about in November 19th, that the selection was made for Tereshkova. She actually finished second in her class of women in terms of exams and competencies and abilities, but she had the right pedigree, which is really interesting, and I think this is very indicative of sort of totalitarian state and who they choose to launch. She was a seamstress, and her father was killed in the Finnish War in the 1930s, I think 1939, and her single mother had raised her and her siblings, and she rose up through the communist system to greatness. And putting her in space was much more impressive than somebody who had grown up with an Air Force background or any kind of sort of family links into these channels. So all of a sudden you have this woman, very, handsome-looking communist woman who really was outright a supporter of the Soviet Union and their political aspects. She kind of was the perfect role model for young women to launch, looking at her, they could say, oh, well, if I stay in the communist system, I can rise to greatness too. And, I mean, interestingly, Gagarin was chosen for the same reasons. He was not top of his class. He was short enough for Vostok, so he made it into the top 6, and he was a farmer's son. He was perfect. I don't know anything about our Chinese female taikonauts' background. Does anybody? I'm sounding no.
Well,
yeah, she's a jet pilot.
She's a pilot, but do you know what her?
In fact, there was a famous story that the Chinese media told about how she was able to land a plane even though a bird smashed into her cockpit windshield. So, but in terms of her family background, I'd have to check into that.
Yeah, it's not obvious whether she sort of meets that same kind of outwardly the perfect person that you want to present to the world as being indicative.
I will say this, that the pictures of her parents that have been transmitted by the Chinese media kind of show them as a regular Chinese family. So they do have that going for them. Yeah,
and it's a powerful image, I think, to say, you can rise to greatness from nothing within our country. So, and we'll see. I mean, it was interesting. I think 20 years until the next Soviet woman was launched, and she beat Sally Ride by, I think, a year. It'll be interesting to see when China follows up with its next female taikonaut, if this is something that becomes standard like it should, or if it ends up being more of a political move than not.
That's really interesting, because you can see with the American space program, they've shuffled women into the astronaut corps and launched them, we hope, just based on merit, based on, there's no real...
Yeah, after Sally Ride, there wasn't a huge gap.
Man, woman, what's the number of women that we should launch to make it politically correct? They have women in the astronaut corps and they're launching them. But you can see with the Soviets, it's almost like they had a checkbox and they went, okay, we've got to make sure we launch a woman because the Americans haven't done that yet. Now let's go back to launching men because that's, they're the strong ones or whatever.
Yeah. So I wonder if first, and it was part of, they were actually going to launch 2 female cosmonauts and have them either both go up in one Vostok or both go up in separate Vostoks and have them rendezvous, which for them meant launch them into orbits that would make them pass conveniently.
So it almost sounds like the bigger accomplishment of this time around is going to be, will they launch women just as a regular part so that it's a non-event as their taikonaut corps, right?
Yeah. Yeah.
And China Daily describes Liu Yong as the daughter of a regular family, born into a worker's family in Zhengzhou in Henan province, and was one of the first women to go into aviation school. So it is that typical, rising from the ranks sort of story.
Even a regular worker here can turn into an astronaut.
Or the daughter of a worker. Yeah.
The daughter of a worker. Yeah. Well, that's really interesting. So I guess that's the question. I think I can see the parallel starting to happen. So if China wants to get ahead of its rising public relations nightmare, it should make sure that it incorporates women regularly into its taikonaut corps.
Yeah, I read a statement that the space program said that part of the reason for launching a woman was because it was the people's expectation, which could be because people expect it to be even, but it could be because people expect certain things to happen, so they're checking off those goals.
Yeah, like a checkbox. Yeah, that'll be interesting to see how this plays out over the time. That's really interesting. I hadn't even sort of really thought about that. So thanks, Amy. Okay, well, Alan, we're gonna sort of finish with you and the momentous announcement of all kinds of asteroid research this week. including a huge scoop that you made on all the rest of us.
Not a scoop, but anyway, there's a lot going on. First, there's this organization called the B612 Foundation, and for years they've been working on trying to raise awareness about the threat from asteroids. One of the things that they've always been talking about is a project to launch a space telescope to look for a particular class of asteroids that are hard to spot from Earth, that spend most of their time inside Earth's orbit. And so this week they sent out an announcement saying we're going to have a press conference about the first privately funded deep space mission, and we're going to send out a Sentinel space telescope that's going to look for asteroids and probably be somewhere in the orbit of Venus, around there. And so actually we're waiting for the other shoe to drop. At next week's news conference in San Francisco, they're supposed to talk about who is providing the money for this. There's an estimate that it requires hundreds of millions of dollars to do this sort of thing. And so who has that kind of money that the B612 Foundation, which was started up by Apollo astronaut Rusty Schweickart and some other asteroid researchers, how are they able to draw upon this money? Who's got money and who's interested in asteroids? Well, it just turned out that a couple of months ago we had a group of billionaires who are backing this project called Planetary Ventures, a commercial project that's aimed at looking for near-Earth asteroids and eventually sending something out there to start mining the asteroids for water that could be turned into fuel for rockets in deep space, or maybe even precious metals like platinum. Speaking of Planetary Ventures, just last night, the founders of Planetary Ventures put out an email blast saying that they were looking for Kickstarter projects. And you would think, okay, they've got at least 4 billionaires backing their project. Why would they have to turn to Kickstarter? But in a way, this is more of a kind of a public engagement move than it is a strictly investment type of move, as so many Kickstarter projects are. It's a way for the general public to suggest ideas that could be added to the Planetary Ventures agenda, maybe put up more space telescopes more quickly, and that way people could have a turn of controlling a space telescope and taking their own pictures. At least that's the idea that the Planetary Ventures founders are floating. And so we'll see how far that goes too. They say that they've gotten hundreds of emails asking about Planetary Ventures and many web hits. There's a little bit of a controversy about exactly how many unique users or page views they've gotten for their website since this news broke in April that they were planning this venture. But it's really indicative that there's a lot of interest in near-Earth asteroids and in participation in space science. The idea that you can be part of the space program is really going to a new level. We've seen all these stories about people sending up balloons with iPhones on them and taking pictures from 100,000 feet high. The next step is to have a Kickstarter satellite, and that's what this group is doing with a new project they call ArduSat, which is a Kickstarter project. They've probably raised their target of $35,000, or they're close to it. That's kind of seed money to get ArduSat started, and the idea is that they would put up a CubeSat, a nano satellite, probably about that big, and you could take a turn at controlling that satellite, doing your own sensor readings, your own experiments, taking your own pictures. It's another example of how people really want to be involved and have a hands-on relationship in space science, as people have done in the internet and all sorts of apps. This is kind of appears to be the latest thing. So we'll see over the next week when the other shoe drops how the B612 Foundation is going to fund their program, what the response is to planetary resources, what ArduSat is going to do, and what else is going to pop up in terms of public participation in the space adventure.
Now, I wanted to grill you a bit more about this, but I know that, Mike, you've got a role. So before you go, I just want to let people know where they can find out more about your work. So where can we find more Mike Wall writing?
Well, I'm just at and space.com. So I mean, we've got everything about spaceflight and space science, and we're certainly following the China stuff and the asteroid stuff, and it's all very interesting. So yeah, I don't know. I mean, we've got about 4 or 5 core writers, and we just try to cover everything, which is very difficult, but
Yeah.
try.
I know the feeling. Yeah, no, that's great. Well, thanks again, Mike. Thanks a lot for joining us, and it's open invitation, so you'll get the announcement. So if you want to get involved any future time, just let me know and just jump in. So thanks
great.
again,
For having me. I really enjoyed it, and yeah, hopefully I'll be back again soon.
That sounds great. All right, well now you can
thanks,
flip out whenever you need to. Thanks a lot.
Okay, thanks. See ya.
All right, now Alan.
Yes, sir.
So I mean, I love the B612 Foundation. I'm a huge fan. I mean, they are astronauts who are taking the threat of future asteroid destruction very seriously, and they've got some really solid plans. I mean, to track these asteroids, land on them, attempt to move them. So I mean, where does this announcement play in their strategies?
Well, it's all part of the effort to track these asteroids. That's really the first step. I know that B612 Foundation and other asteroid researchers have talked about, well, what are you going to do if you ever find an asteroid that poses a threat to Earth? And that is what the foundation has been working actually with the UN and the UN Office on Space Policy to try to work out what's going to happen. Because if you try to move an asteroid, there's going to be a point where you may move it so it's not pointing at New York, but it might possibly point at Moscow or New Delhi or Beijing. And so you have to be very careful about the liability and the risks that are involved when you try to actually do something to put an asteroid in a different direction. And there are all sorts of ways being talked about to do that, throwing something at it, you know, a nuclear bomb to break it apart, or using a gravity tractor where you have something that is massive that gets close enough to actually impact the gravitational pull and the direction of the asteroid. So if you've got many years to change the course of an asteroid, you have more options in figuring out how to do it. But this is, I think the foundation would definitely agree that this is just kind of a first step, but it's something that they feel is very important. Scientists have figured out that maybe 90% of the really big asteroids, the ones that are bigger than a kilometer, have been found, but only about a third or less than a third of the asteroids that are between 100 meters and a kilometer have been detected so far. And those are the ones that may not, you know, be a global extinction event, but it can really take out a city if it just hits in the wrong place. So the foundation is getting involved, and I think that you're going to see a lot, if they can pull this off, you're going to see a lot more debate about, no one is going to ask anymore, well, what good is the space program? You know, people have said the reason the dinosaurs aren't around anymore is because they did not have a space program. So yeah. I think that could energize this whole debate over what good is it to send things into outer space.
Yeah, that's a really good point. And I think that, so, I mean, because only a fraction of these asteroids have actually been discovered, you build the Sentinel system and then you find them all. And you could almost, I mean, from what I understand, if you did a good enough survey job, you would essentially be able to rule out asteroid strikes within certain time periods of certain scales. You could say there will not be a global extinction event within the next 1,000 years. Guaranteed.
Yeah. I don't know of anybody who would want to guarantee anything like that in science. You've got long-term comets that could come in from the blue.
That's of course true. Yes, you'd have long-term comets. Yeah,
but it would make
known big asteroids.
Yeah, it would make people feel a little more comfortable about you know, the long-term prospects for the species, and give Elon Musk a chance to get that Martian colony started.
Yeah, absolutely.
And that's the thing, because it's a severely underfunded field. I mean, there's only like there's a handful of these space watch groups around the world, and most of them are in the northern hemisphere. It was like only, was it last week, there was a discovery of a fairly large, hefty piece of space rock. I forget how big it was, and it was discovered like a day before, it's going to do its close flyby of Earth. And imagine if, and this was like a city killer, this thing would wipe out a city if it hit us. But it was discovered in the southern hemisphere where there's not very good telescope coverage. So, you know, there's obviously an issue here. We don't have, we don't have, I mean, with asteroids, we just don't have the luxury of, you know, not worrying about it because it could happen tomorrow. I mean, as that asteroid showed. I mean, it was funny because I follow Asteroid Watch. I think it's the JPL office of NASA's Asteroid Watch. And the person who was tweeting said he was astonished by all the attention this asteroid brought. You know, it's totally safe. There's no issues here. My response to him was, you discovered it on the day of close approach. Imagine if that was pointing towards us. Yeah, it wasn't pointing towards us. It was completely safe. It was like well beyond the orbit of the moon. If that's not the issue here. It's the fact it was discovered so late. And I think that is something, I mean, as you know, as you guys are saying, if we can have more surveys, we can start having a better idea and a better feel for just how many asteroids are out there. And we know 90% of these big planet killers. I mean, we know there's nothing really massive that could wipe out all life on Earth, certainly not within the next few 100,000 years. But those aren't the ones we're really worrying about. We're worrying about the ones that can cause huge tidal waves, or ones that can cause, you know, Moscow to be wiped out, or, you know, just ones that can really just devastate our economy. Because imagine if an asteroid hit a financial center, it would be world meltdown. I mean, there's no two ways about it. It would be a huge disaster. And those are the ones we need to look out for, and those are the ones we can actually deflect. I mean, forget about the huge dinosaur killers. If that's coming towards our way, it's going to take a real big leap of the imagination to know how to stop them. But it's the smaller, you know, perhaps under a kilometre size, we can actually do something about. So more money. We need more money, and more of these foundations that actually, you know, are concerned about this and raising people's awareness. So
I suppose the reason why the B612 Foundation has been doing this is because they've been frustrated with you know, trying to get the resources from governments to do this. And so you're right that the asteroid detection part of it is really key to giving yourself enough time to figure out what to do about it.
Yeah, I am all for it, and I'm also for them trying to chart this on their own and try to raise their own money and raise awareness separately from within necessarily having to go through the standard channels. I mean, if they are successful, then probably, you know, just like with SpaceX, you know, SpaceX moved forward, built their spaceship, raised their finances, and now they're getting contracts with NASA. I think it's the same way. You know, if they can start to build some of the hardware, get some launches organized, get this telescope moving forward, NASA may be able to kick in some financing later on to help sort of move it to the next step. But I think, you know, it's better to kind of move first and ask for forgiveness than to ask for permission, you know. I think that's a good way to go about it. Cool. Well, let's take some questions. So if anybody has any questions for the panelists this week, you can go ahead and post them in the Google Plus comments. You can post them over on YouTube, or if Twitter's back, you can use the hashtag Space Hangout, and we'll tackle some of those questions. So Jonathan Langdale asks, might the eyesight problem be related to including a woman? Maybe they'll all be women eventually. So I guess we talked about this a few months back. I think Ian, you were the one who talked about this. The fact that one of the big hazards of spaceflight that's been recently uncovered is the problems with astronaut eyes, that they actually are getting some eyesight loss. Did you work on that story, Ian?
Sorry, can you hear me? My computer's been messing up.
Oh yeah, so we're mentioning that the one of the possibilities of including women in future missions is related somehow to this eyesight problem that the astronauts have been facing. Yeah.
Yeah, I don't know about women in particular. I mean, is that really the question about you know, whether women's eyesight is better in space?
What's the eyesight problem? What's the issue that's coming up?
Yeah, there's this degradation of astronaut eyesight when they're in space for long periods of time. I think it's not a radiation issue. It's a gravity issue. I think it just changes the shape of the eye.
Yeah, that was an issue in the 50s, that it was, would they be able to see because their eyes aren't supported, they'd change shape and it would give them tunnel vision or blurry vision. And
but there is a degradation. I forget what that story was. Yeah, I think I did mention it.
Did you work on that one at all, Alan, about the eyesight problem?
I didn't write that story, but it is an issue. They're trying to figure out what causes the eyesight to degrade, and that effect continues after the space flight. And I think in some cases they found that it took a long time to bounce back from that issue. But I don't think that there is any gender difference in how that works. The one thing that they do talk about with the Chinese flight is that they try to find women who have had children already because they're afraid of the effects of space radiation on the fertility or the ability to give birth. I don't know how much there is to that. I don't think that that's been a concern for NASA, but that's a reason why that has been cited by the Chinese for selecting the people that they've selected.
Yeah, Jonathan is mentioning in the comments that he thinks that the eyesight problem was for males, that men have a tendency to go farsighted more than women. So, and so maybe that's a sort of an issue. None of us have enough information about that. So, Gary Ganella, one of the astronomers from our Star Party, mentions that as it relates to the asteroids and some of the Kickstarter projects, that they need to get the hams involved. Need to get the ham telescope, ham operators, the people who broadcast on their ham radios, because there's the amsat.org, and they have actually they've been launching satellites for like decades now. Same thing, they gather together their own funding and they launch a small satellite, and they've done this for years and years.
That's right. Yeah, I think recently there was a CubeSat mission, and it seems to me that there was a CubeSat that was deployed from the International Space Station recently that was related to amateur radio broadcasts. I'd have to look up a little bit about that. But,
yeah, when you say deployed, what it really means is thrown.
Yeah. Although they do have capability on the Japanese external platform to take the robotic arm and kind of open a door and have a CubeSat come out that's spring-powered or something like that. And that's a way that this company called NanoRacks is proposing to launch CubeSats from the International Space Station in the future. We'll see.
Yeah, and it's like with these CubeSats, they are very inexpensive. So you often hear about student projects. The students building CubeSats, and they're going to get put on the next flight into space. And because they're very, very small, very lightweight, and because they're microelectronics, they can do fantastic science in space. So I could imagine, having an armada of these small satellites becoming our in-orbit sentries for protecting us from space rocks, perhaps. Who knows?
So Jonathan has been digging in the background here. It's quite interesting. So he says, in a separate NASA survey of 300 male and female astronauts, about 23% of short flight and 49% of long flight astronauts have said they've experienced problems with both their near and distance vision during the missions. So that's pretty significant. About half of the astronauts on board the International Space Station have developed an increasing pressure in their heads. This intracranial pressure that reshapes their optic nerves, causing a significant shift in the eyesight of male astronauts. And doctors call this papilloderma. So that's it. So that's why we need to have women in space, because they won't go blind. All right. Well, if anyone has any more questions, that would be great. I don't see any more questions right now, so we're happy to answer them. But until then. We will keep. I will close. I'll begin the closeout ceremony. So if people want to find out more writing from everybody, how can they find out more about you? Alan Boyle, where can we find you?
CosmicLog.com and also space.msnbc.com. What I write is Cosmic Log, but we have a full lineup of stories, including stories from Mike Wall and the other good folks at space.com.
Yeah, I know that you
And
you guys have a partnership.
Ian has, and we have a partnership with Discovery also. So
And us.
Yeah, and Universe Today.
There
We're
we go.
one big happy family now.
We are really one big.
No
I love you all.
Yeah, it's just share and love.
Yeah.
Ian, where can we find out more about you?
Go on to discoverynews.com. I'm the space science producer over there. I'm always blogging. I would also my personal blog astroengine.com is still vaguely alive when I get time to update it.
Who has time for that?
Discoverynews.com.
I gave up and I just forwarded my personal blog to Google Plus. I just don't have time to blog
There's
there.
no time to write now. It's just ridiculous. The universe won't stop doing stuff. It's just ridiculous.
When I started like 12 years ago, and I'm sure Alan will back me up on this, it was hard to find stories every day. There might be a couple of press releases every day, and one of them was meh, and the other would be good. So, you were working on stories for a couple of days because there just wasn't a lot of stuff out there. Now, my feed reader fills up with thousands of interesting stories that I could look at every single day now. It's absolutely mind-bending.
I think also because I've noticed like research institutions, they are getting very savvy with PR releases, and which is fantastic. And also everybody's on Twitter, everybody's social mediaing like crazy. So you've always got to feed to these guys. And this is one thing I've been saying for ages. It's like if your research group or space group or any application group, if you don't have a really big social media presence, you won't get noticed. So I think everybody's kind of paying attention to that, and they're releasing press releases left, right, and center. I mean, it's like now I've got like 5 things I can't get to, so I have to prioritize them.
Yeah.
And gone are the days when I used to write for you, Fraser, and I used to do 5 blogs a day. It's like I think it comes a certain thing with age that you just kind of slow down. So one a day is good for me.
Yeah, but Amy has got tons of energy. So where can we find your work, Amy?
AmyShiraTeitel.com is my personal site. My blog Vintage Space is there, and it's got links to all the stuff I do everywhere else. I'm also on Discovery News and elsewhere. So yeah, look for me there. Find me on Google Plus. Lots of space history. Fun times.
Great. Okay, and so then the next thing interesting that's going to be happening here on Google Plus is we'll be doing our virtual star party, and that's going to be on Sunday night when it gets dark on the West Coast. And as you know, we just hit the solstice, so we're at the latest point of the summer, and so usually we're starting around 9 o'clock right now, 9 p.m. Pacific Daylight Time. Would love to do some stuff earlier if we can get some more telescopes in other parts of the world, but right now that's when we have to get cracking. So, but still, Sunday night after 9 o'clock, join us and we hook up a bunch of telescopes live and broadcast views of the night sky. So it's pretty cool. So thanks to everybody watching. Thanks to all of the participants this week. Thanks to Mike Wall, who had to leave us to get the jump on some big piece of news that's going on right now. So thanks to everybody, and we will see you all next time.
Live long and prosper.